Assalamualaikum and a very good evening to Dr. Isha. We are BMFI students from Group 8. So today we will present to you about our project for project design and manufacturing course. Okay, first of all, I will introduce to you our group members. I am Dia Ani Akmal bin Muhammad Anwar as the group leader. Next, we have Rusdi bin Zainul, and then Dennis Nawin, and we have Tan Sufei and Tan Jaki. Okay, this is the table of contents. First, we will talk about executive summary and then CAD model, engineering analysis, cost estimates, and sustainability. First, for executive summary, we have done our site visit at TerraTech Ventures Neighborhood, which is a company that repairs and operates electrical components such as television, laptop, refrigerator, and washing machine. Based on our observation, the workers have difficulties to find spare parts for a certain model because of the storage room was too messy. So we held an interview session with the owner and the workers at the company, and also we've done a brainstorming session among the group members to solve the problem. So that's why we came up with the ideas of a smart rack that using IoT system where the worker can easily access to the smart rack through their mobile phone or any other device. Next, for CAD model, we use CATIA and SolidWorks to design our product. As we can see here, the drawer have three sections for three different types of model. For example, for the first section, we only keep Sony spare part, and the second section, we will keep Samsung spare part only, and the last section, we will keep Toshiba spare part. And for each drawer, we have put at least 10 rack divider to keep the component in straight and tight position. We also design the door handle to make it easy for the user to open the drawer, and then we put wheels at the bottom of the drawer so that the drawer is portable and easily can move it around. For main body, the material that we use is aluminum profile for the frame body, and then we will use acrylic to cover the aluminum profile. Why we use why we use acrylic? Okay, we use acrylic so that we can see through the drawer and we can notice how many spare parts left in the drawer. So the method that we use to attach the acrylic and aluminum profile is we use bolt and nuts for the body, which is the aluminum profile. So to attach the aluminum profile to make the frame body, we will use bolt and nuts, and then to attach the acrylic to the aluminum profile, we will use screw and nuts. Okay. Next, for rack divider, the material that we use for the rack divider is PVC sheets or plywood. Okay, why we use this material? Okay, because this material can easily find in the market and also cheap, so we can reduce our cost for the material. And the method that we use to attach the rack divider is mortise method because it is strong and reliable. Okay. Next, we have door handle. Okay, for this part, the material that we use is EPS plastic, and the method to attach the door handle to the drawer's door is screw and nuts.
For the drawers door, we use material called acrylics. We use this material because it is lightweighted. Acrylic sheets are considerably lighter than traditional door materials like wood or metal. This makes acrylics door easier to handle, install, and operate. Okay, for wheel, we use material made by cast iron. We choose this material because of its strength and durability. Cast iron is known as its exceptional strength and durability. It can withstand heavy loads, shocks, and impact without deforming or breaking. This makes it an ideal material for wheels that need to support substantial weight or endure tough conditions.
Okay, now I will explain to you about the economic analysis. For economic analysis, we are using rapid limb upper assessment, which is ruler analysis. It is an economic assessment tool used to evaluate and analyze the risk factors associated with the upper body's posture and movements during work tasks. So, the ruler assessment was conducted through CATIA. So, based on the figure and the ruler score results, we achieved 3 for final score. Although it is not a good result, but we can see through the ruler score table that there is no red color shown. If we analyze the details of the table, we can see that the most affected part of the body is the upper arm, wrist, and arm. As the figure shown, the posture of the upper arm is quite stretched upward in an awkward position. Besides, we also notice that the wrist and arm are stretched forwards too much, so which make it an awkward position for the person. So this may cause fatigue and overstretched muscle to the user that lead to the less productivity. So after the discussion session with among the group members, we may need to change the height of the product, and also we can suggest to the worker to place the product on the lower height shelf. Thank you.
Good day, Doctor. I'm Dan Jiaqi. Today, I will present about the cost analysis for project design manufacturing product smart organizer. First, the cost. They have three types of cost in the cost analysis. They are material cost, fixed cost, and the variable cost. In this slide, I will present about the material cost. Material cost is the expense associated with the actual material used to create a specific good or deliver a particular service. So, in the table of the material cost, the first column we list out all the material we need to use to produce a smart organizer. Example material are acrylic, aluminum profile, ABS plastic, plywood, PVC sheet, wood board, caster well, hinge spring, and the light indicator. And the second column we put the material size, and the third column we put the amount for each material, and the last column we put the cost for each material. Besides that, we also can see that in the last row of the table, there are the total material cost. So the total material cost for produce a smart organizer are 353 ringgit 65 cent. Next, the second cost for the cost analysis are the fixed cost. Fixed cost is the cost that are the same regardless of how much a business produce, like example the land, property tax, insurance, and depreciation which are unrelated to a company specific business operation. So from the table of the fixed cost, we can see that the first column is the we list out all the expenses, and the second column we this the expenses cost. So the first expenses is factory land. We need 200 ringgit for the factory land, and the second is we need 200 ringgit for the equipment, and the last one is we need 150 ringgit for the utility and salary. So the total fixed cost is we sum out all the expenses, and we get the total is 550 ringgit. As we know, the cost in the cost analysis are the variable costs. Variable costs are the any expenses that vary according to how much a business produce and sells. As the result, the variable costs will go with rising production and also will diminish with falling production. So the example of the variable costs are the material cost, labor cost, utility price, and also the commission. The table in the below are the table variable cost for reproducing produce a smart lab organizer. So the first one we can see that we need 353 ringgit 65 cent for the raw material, and also we need 15 ringgit for the overhead and 25 ringgit for the labor per unit. So the total variable cost we need to produce the smart lab organizer is 393 ringgit 65 cent.
A very good day, Su Doctor. My name is Tan Su Fei, and I will present the break-even analysis for the cost analysis part. Okay, so break-even analysis is the financial computation that compare the cost of starting a new firm, service, or product to the unit sale price to calculate the break-even. So the break-even point, it actually indicates the unit that need to be sold to cover up costs, such that fixed costs and variable costs. Okay, so we know the raw material cost is 353.65 cent from previous slide. So the profit we take for this case is 30%. So we will take the raw material cost, which is 353.65 cent. We multiply by the profit percentage and we will get 118.10 cent. And to get the selling price, we will take the raw material cost plus with the profit amount per unit. So 353.65 cent we plus with the 118 and 10 cent, and total we will get 471.75 cent. So this 471.75 cent is a selling price for our product. Okay. To calculate the break-even point, we take the fixed cost, divide by selling price minus variable cost, and we will get total of 7 unit. And to calculate the break-even price, we take the 7 unit multiplied by the selling price, and we will get total of RM3302.30 cent. And if we refer to this break-even chart, the x-axis represent the unit and the y-axis represent the amount. So the blue color line represent fixed cost. So it remains the same throughout the unit because it does not vary with the output. And the yellow color one represent revenue, the gray one is the total cost, and the red one is the variable cost. So at point number 7, we can see that the revenue and the total cost intersect with each other, which means at this point number 7, the sales volume is equal to total cost. And after it exceed the number 7, after unit number 7, the revenue is now higher than total cost, which means that we are making profit. And if it below 7 unit, then we can see the revenue is lower. The revenue is lower than the total cost, so we are suffering from loss. Thank you. To calculate the profit, we first need to calculate the total revenue. So in this case, we make an assumption that the sales volume are 30 units. And so total revenue is the selling price multiplied by the sales volume, and we get total of 14,152.50 cents. And to calculate the total cost, we take the fixed cost plus with the variable cost multiplied by sales volume, and we get total of 12,359.50 cents. And last, we will calculate the profit. Okay, so for profit, we take the total revenue minus by the total cost, and we get 1,793, sorry. So this is the amount that we get if we were to sold 30 units. And that's all for break-even analysis. Thank you so much for listening.
Hello everyone, my name is Desnami and I'm Paling. I'll be talking about the sustainability of our product. Design for environment is a design methodology that uses to lessen how harmful product processes or services are to the environment. It takes into account the entire life time of product from the raw material production to disposal. In the case of our Smart Organizer project, we are using DFE to reduce the environmental impact of the project in several ways. First, we are using recycled material in the construction of the track. Second, we are designed to the rack to be as energy efficient as possible. Third, we are making the rack easy to disassemble and recycle at the end of its life. By using DFE, we are confident that our smart rack organizer will have significantly low environmental impact than traditional rack organizer. We believe that this is an important step in the development of more sustainable products. The objective of our sustainability is to improve productivity and reduce costs without affecting the environment to maximize the usage and importance of recycled materials for packaging or disposal while minimizing environmental consequences. So now I will talk about the design for environment guidelines that contain five main aspects, which are material extraction, production, transportation, distribution and packaging, usage, and lastly, end of life. Okay, we start material extraction. Firstly, use environmentally friendly, ethically sourced, and minimally harmful materials, which mean lessen the amount of non-renewable resources that must be mined from the environment. Secondly, to extend the life of the smart organizer, choose recyclable and robust materials, which means reduce the amount of production-related material waste. Thirdly, reduce the amount of material used, which means boost recycling and simplify the sorting process. Production. Firstly, optimize the manufacturing process to minimize energy consumption, water usage, and waste generation, which means implement lean manufacturing principle to reduce inefficiency and optimize resource utilization. Secondly, avoid use of hazardous substances during the process, which means substitute toxic material with safer alternatives wherever possible. Comply with international regulation and standard to ensure the body is free from harmful substances. Thirdly, establish a sustainable supply chain by engaging with suppliers that adhere to environmental standards and practices, which means collaborate with suppliers to reduce the environmental impact of the manufacturing process. The fourth, implement waste minimization strategies such as recycling, reusing, reducing waste generated during the production process, which means optimize material usage and consider implementing closed-loop system to recycle or repurpose manufacturing waste. Lastly, ensure the health and safety of workers involved in the production process, which means implement safety protocols, provide necessary protective equipment, and train employees on safe handling practice to create a safe working environment. Transportation, distribution, and packaging. Firstly, optimize efficiency transport. Transport by van is preferable over transport by lorry. Prioritize safety during shipping by ship, which means decrease energy use and emission from transport and avoid environmentally harmful ways of transport such as flights. Secondly, maximize use of refillable or reusable container rather than use not appropriate materials for packaging, which means decrease the amount of toxic, hazardous, or valuable materials in waste. Lastly, minimize the amount of packaging material and the number of materials in the packaging, which means decrease amount of material needed for packaging, reduce cost to aid the recycling of materials. Usage. Firstly, optimize energy usage during operation, which is mean implement features such as power saving modes, automatic shutdown, and scheduling mechanism to reduce energy waste when the rack is not in active use. Secondly, enable remote monitoring and control capability for the rack. This allows users to efficiently manage and monitor the rack performance and optimize resource usage. Thirdly, utilize real-time data analytic capability to gain insight into inventory management. This enables protective decision making to optimize resource usage, prevent wastage, and reduce environmental impact. Lastly, implement advanced inventory management feature in a smart rack. This helps optimize stock levels, reduce overstocking, and minimize waste due to expired or unused items. By accurately tracking inventory, companies can better planning and reduce unnecessary resource consumption. End of life. Firstly, the smart reorganizer should be recycled or compost at the end of its life, which means Recycling or composting the smart organizer will help to conserve natural resources and reduce pollution. Secondly, the smart organizer should not be sent to a landfill. So, sending the smart organizer to a landfill will contribute to climate changes and other environmental problems. Lastly, the smart organizer should be disposed and on off in a way that minimizes environmental impact, which means disposing of smart organizer in a way that minimizes environmental impact is the responsible thing to do.
For recommendation for design for environment is choose environment friendly materials. It is because it gives preference to sustainable and low impact materials during the design process. Secondly, energy efficiency product design, the drawer and the feature that prioritize energy efficiency. Thirdly, use-friendly design. It is because use features that are intuitive, easy to use and easy to maintain. Okay, fourth is prioritize safety feature on the products. With our feature more or less mapped out and validated, we have to look at which one are most important to work on first. Lastly, reduce product chemical emission. One way to lower emission is to focus on chemical plants by improving efficiency and switching to low carbon energy.